Ronnie. I work for CA Technologies in a group called the API Academy. I don't know if you guys know the API Academy. Does anyone? A few of you. All right. There's a few of us, and we don't sell product or anything like that. We talk about API design. We do research, speak at conferences, attend conferences. There's been good practical sessions today. A lot of good advice. And that's the end of it, right? There's no practical advice in what I'm about to talk about here for the next 30 minutes. This is just, I had this itch I've been wanting to scratch in terms of a topic, and this was an opportunity to kind of explore this idea of simplicity and simpler things. So be patient with me and come along with me. Maybe we'll find something useful out of this, but you know, I'm not going to give you anything you can use today, so I'm sorry for that. But we all seem to care about this, right? Simplicity. Simplicity seems to be a very important design goal. When we think about the products that really excite us, the ones we hold up, right? We think about products like this. There's so many people who write about how amazingly simple the Google search page is, right? How we went from that Yahoo portal we saw earlier with all this stuff happening, very complex, to this simple search page. This company's products also embody this idea, right? People love this idea of things being light and free and clean and uncluttered. And I noticed that permeates into how we talk about APIs as well. I grew up with a lot of SOAP implementations, right? In my enterprise career, I did a lot of SOAP. And then over the last few years, we kept hearing that SOAP is complex and people want simpler solutions. And the simpler solution seems to have won, right? So this idea of simplicity seems to have something to it. The reality is I don't want to talk about simplicity. I just said that so you'd come to the talk. It's really about complexity. Complexity is what I want to talk about. Complexity is more interesting. And this is the itch I've been wanting to scratch, right? What does complexity mean, and what does it mean in our domain of APIs? Inside of the academy, we talk a lot on Slack. Do you guys use Slack? Little chat room, right? And what I noticed over the last few months, I had some ideas of what complexity meant. But I started realizing this was coming up a lot. And what I thought complexity meant didn't necessarily mean what my colleagues thought. And I started doubting myself. So I thought, what better way to learn about this than to do a talk about it in front of all of you? So what you're seeing is kind of my digging into this space. So let's talk about complexity. I'm not going to do a dictionary definition because that's cliche, but I'll describe what I think the kind of properties are, the features of complexity, right? The first things that come to mind. Definitely complexity means there's lots of things involved, lots of parts. But it's not just that there's lots of things. When we think about complexity, we imagine some kind of interconnectedness, intricacy. If I move one part of a complex machine, some other part might move. It might have some unintended consequence. And probably the biggest one, the way I always thought about complexity was in terms of processing, right? How easily could I understand something that's complex? This is why complexity is often thought of as the enemy, right? It takes more resources to process things that are complex. So we don't want complexity, right? We want simplicity. In digging into the space, it turns out there's all these different categories of complexity too. And classically, I had always kind of thought and talked about interface complexity. This kind of, how do I process things? But there's this whole other world of systems complexity, and there's computational complexity. I want to spend just 5 minutes on system complexity, and then we'll talk about interface complexity. System complexity, unfortunately for me, is very formal and based in mathematics, so it's quite hard for someone like me to understand. But there's a few good books, right? If you're a layman like myself, there's a Complexity, Very Short Introduction by John Holland, and Melanie Mitchell has this book, Complexity, A Guided Tour. So first I got to ask, is there anyone in here who really understands systems complexity? Any science people? Brian, okay. I knew you might. All right. Here's what I learned. Okay, here's my book report. when it comes to system complexity, the characteristic, the thing that defines systems as being complex is this idea of emergence, right? This comes up again and again. And the idea is if we have a system that behaves differently when everything is together, that's emergence. So a more formal definition, when the action of the whole is more than the sum of the action of the parts, that's emergence and that's complexity from a systems perspective. And that's, again, one of those things that you can read and understand, but without an example, it's tough. But in this case, with a flock of birds, we can understand how birds might behave on their own. But that doesn't mean we can necessarily predict how a flock of birds flies when they're all together, right? In fact, part of what makes complexity interesting is that it's nonlinear, that it can be difficult to predict, right? There's also these different categories. There's complex physical systems. Systems that are based on elements, things like the weather, where we have air molecules and heat from the sun. The elements themselves don't change, right? An air molecule is an air molecule. But they move around, they interact with each other, and that creates a complex system like the weather. But where people get really excited is in these kinds of systems, adaptive systems, right? Complex adaptive systems. And in these kinds of systems, we don't have elements. Instead, we have agents. And agents change their behavior over time. So now we have a system where on day one, an agent might behave one way, but as time goes on, based on changes in the environment, based on things that happen around it, it can change its behavior. And in the complexity world, they often talk about economics and markets as a complex adaptive system. Originally, people might have thought of the market as a simpler system, right? Where you find an equilibrium based on perfect rational knowledge. But the complexity view is that no, people make irrational decisions and they actually change their behavior based on what's happening in the market, based on what other people do. So we end up with this system that becomes almost even more difficult to predict. And it's very rare to find steady state or equilibrium. So how does all this happen? Well, Holland describes something called agent structure. Here's how agents adapt. Here's how they exhibit this behavior. The first thing they do is they have this idea of performance first. They determine what they'll do in any point of time. So in a stock market, maybe an agent decides, well, based on this condition, the stock price being low, I'm going to buy stock. The second thing these do is they apply credit somehow. They review the activities they've taken. They look at their behavior and assess it and score it somehow. So maybe the price has gone down and we've lost money. We executed that activity and here's the result. And we do it over time and we score that result. And ultimately you end up with rule discovery. Agents that are able to come up with new rules, new strategies, new ways of solving problems. But here's the fascinating part. We're not talking about artificial intelligence here. These are agents. They can be components that have very simple logic, right? Simple ways of experimenting and trying new things. But it's only when the system is all together as a whole that it demonstrates this emergent behavior that can be much greater than the behavior of an individual piece. So here's why it's interesting. When we get emergent and adaptive behavior, we start seeing specialization and diversity in the system. Some agents became very good at doing certain things. Other agents become better at doing other things. What we also notice is that now behavior is decentralized. There's not a controller telling everyone what to do. The system as a whole has its own behavior. And most importantly, the system can adapt to change. So these features probably sound familiar to us, right? These are the kinds of things we're looking for more and more nowadays in architectures. But my passion has always been more on the interface side, right? Things like usability, experience, that's the stuff I like to dig into. So if we look at interface complexity, here's a very different remote from that Apple remote earlier, right? It has more buttons, there's more going on. If we look at complexity in terms of design or cognitive complexity, there's two books that are probably the go-to books, right? One is John Maeda's The Laws of Simplicity, and the other is Donald Norman's Living with Complexity. These are two completely opposite ends, right? Maeda's book is about simplicity, this beautiful thing. Maeda even has this persona of being more artistic. They both went to MIT, they're both engineers by background, but Maeda is all about form. When you read his book, it's almost like reading a book of philosophy, right? It's a very beautiful book with 10 laws. And Norman's persona is much more, questioning the world. Why does this not work this way? Why can't I open this door, right? That kind of mentality, and he's able to explore that way. So they start from different ends, but largely they end up with very similar conclusions. So in Norman's case, he realizes that complexity is not the problem, right? It's actually confusion that we want to avoid, which is very different from what we think. What Norman says is complexity is in the world anyways. You're not supposed to eliminate complexity. You're only supposed to eliminate confusion. Maeda, for his part, comes up with these 10 laws, and we're not going to go through them, but they're very similar in spirit, right? We want to reduce things, get rid of cruft, but also understand that complexity is part of the world and find a way for it all to fit together. The law he's probably well known for is this last one, where he says simplicity is about subtracting the obvious and adding the meaningful. Right? So somehow we have to get rid of things to make them simpler, but still add things that are useful. All right, so what all of this means with these two viewpoints is that we could have two things. Here's two steering wheels. I think it's fair to say the steering wheel on the left is simple compared to the steering wheel on the right, because the steering wheel on the right has more things, right? It's more complex. But what also becomes obvious is the steering wheel on the right, with all of its buttons and dials, is still designed, right? There's still an attempt to make usability a priority. There's colors, there's groupings, there's a logic to it. We can imagine the driver can easily hit the buttons without moving his hands off the wheel. It's optimized for whoever's using that steering wheel. And of course, context matters too. We know that these steering wheels are for very different kinds of cars, right? In a race condition, this car and this steering wheel probably would not be ideal. So complexity is not just about when there's lots of stuff, right? That's not the problem. Complexity then has to become about perception, or rather, it's only a problem if we have something that's complex and in its perception, it's perceived as confusing. So your job, when you design APIs and systems and architectures then, is to manage that complexity, right? You have to do these things. You have to improve the learnability. You have to make your interfaces easy to learn, improve the usability, reduce confusion, but it doesn't mean you have to take your complex business space and offer it as a very simple API with less function, right? That's not what you need to do. You need to design the interface, but it's okay to embrace and accept the complexity inherent in your business domain. The trick then comes in managing complexity, right? That's the skill. So how do we get complexity in the first place? The way I look at it, complexity is the price we pay. When we add function, feature, when we add utility, right, we get complexity, whether we want it or not. So the mouse on the left has a single button, right? It's a simple mouse. It's easy to use. Someone could easily learn how to use that mouse, but it's not fit for all purposes. In fact, that would drive me crazy only having one button personally. The mouse on the right has many, many buttons, but of course has added complexity. It's more difficult to use. We could say the same with remotes, right? This remote might be good for some purposes, but we need more functions, more buttons often, otherwise we're unhappy. So there's this price we pay, right, for utility. And this is epitomized really well by Fred Brooks. Now he's talking about coding, right? Creating software. And he wrote this paper called No Silver Bullet, where he describes two kinds of complexity that always come up. There's essential complexity and accidental complexity. Essential complexity is the complexity that if you remove it, you basically take away the soul of the software that you're writing, right? The whole reason you wrote the code to solve certain problems disappears when you remove this essential complexity. And the accidental complexity is kind of the cruft, the stuff that you can remove. Maybe it's leftover, maybe it's unnecessary, or maybe there's just easier ways to get the job done. You might be familiar with Larry Tesler, right? Has anyone heard of Tesler's law of the conservation of complexity? Tesler actually invented copy and paste in Xerox PARC, right? So it's pretty good. Credentials. He had a project where he was introducing a framework in a library, and to sell that internally, to get people to buy into the idea of abstracting something and pushing it down in the stack, he came up with this law, right? It kind of mirrors what Brooks was saying. When we create something, there's an essential complexity, and we can't get rid of it, and the only thing we need to concern ourselves with is who is going to pay that price. Someone always pays the price of complexity. It doesn't disappear. Just because you don't see it anymore doesn't mean it's gone. Someone pays. So to illustrate this, let's look at OAuth 2, I guess the unofficial sponsor of Nordic APIs, right? OAuth 2. So here's a question for you, Travis. Is OAuth 2 complex? Yes. Yeah, so complex, right? Like, it's the poster child for complexity. And if we think about it, especially compared to OAuth 1, it makes sense based on what I've been saying, right? We added all of this utility in OAuth 2. We went from one prescriptive flow of how to do one thing to now this framework with 4 flows. It's good for conferences, but it's got so much stuff in it, right? So many moving parts. It fits that idea of complexity. And yet, it's really part of our stack. It's a de facto part of our security stack now, right? We all use it, almost all of us. So why is that? Why is it okay to use something this complex? Why did complexity win? One way to understand this is to imagine that we could take the complexity of OAuth 2 and pour it into this cup. And then if we apply Tesler's law and look at an architecture of an OAuth 2 implementation, what we see is that the person who pays the price is the server implementer, not the client implementer, right? And if we think about the nature of the business we're in, we care about this user, right? So suddenly the cost is justifiable. OAuth 2 makes sense because I pay the price. Now there's a bigger picture story here, right? This is a security implementation, and increasing the complexity of a security implementation is a bit of a problem. But in terms of the people who have to adopt things like OAuth 2, this is a no-brainer. I absolutely want to implement something that gives me utility. I will pay that price. And here's the other interesting thing that happens when we see scenarios like this with complexity, but also people are willing to pay the price. That's where companies like the ones who have sponsored this conference will step in and say, hey, I've got something to sell you, right? So this is an opportunity to hide complexity. And now suddenly, everything's a bit nicer. And this is a pretty common pattern, right? So design and architecture suddenly becomes all about finding out what the essential complexity is and then moving it around. Trying to find out who can afford to pay that price and making it make sense. Another good example of this is microservices, right? We're hearing a lot about microservices. I'm not going to try and define it, but we know there's certain properties, right? Like decomposition. So here's the monolith, and we know it can be decomposed, split up into smaller services, right? Everyone's familiar with this? Yes? If not, read up on it. Who pays the price of complexity in a monolith, right? I guess it depends on who we ask, but if I divide our world into 2 groups, into code maintainers and system maintainers, in the monolith application, I could argue the code maintainer pays a big price, right? As the complexity of this application grows, the person who has to maintain the code inside of it, needs to know more and more about what's happening, the interdependencies, all the details. While the person who maintains the system, who takes care of releases and maintenance, and who has to understand holistically how all the pieces fit together, has less pieces to deal with. We could ask the same question about microservices, and we know the answer, right? It actually looks quite different. In a microservices architecture, the system maintainer pays the complexity price. This is the trade-off. Microservices are easier to digest. Learnability improves. It's less confusing. It's easier for me to make changes to the code. But now someone else has to deal with more moving parts. We shift complexity to the system. Now, in microservices, it's almost like we're making this big trade-off. We're going to trade this kind of interface complexity or cognitive complexity for additional services complexity, right? Or system complexity. But just like the OAuth case, what we're seeing is for a lot of organizations, that complexity cost is worthwhile. It's worth paying that cost, right? And again, we're seeing a flurry of tools enter in here. And I don't have an exhaustive list off the top of my head. You know, containerization and deployment and discovery are all fitting in there so that people can continue to go forward and hide that complexity in tooling. But one area where I guess I'm a little bit concerned as we go forward is where the boundary is, right? When we think about things like microservices, even if we're thinking about bounded contexts, thinking about the models, I can't help but feel like all of this is just implementation, right? So we could draw a box around our system. And it doesn't really think enough about the client application. And our roots in this room for designing interfaces are supposed to be about thinking about client applications. So we almost have this head-on collision. We increase the complexity here. And if we don't do anything, we also increase the complexity for client applications. Suddenly they're having to make many calls. They're having to understand your bounded context, your business models, your data models, and that can be dangerous, right? So now the complexity cost looks a bit different. We're seeing client app developers now paying part of that cost, and that's not what we want if we're building APIs in competitive markets. Now, that's not something that microservices people don't know about, and in I think a popular opinion, what you'll see is this. We move the complexity now into an SDK. This is a pretty common pattern for microservices architectures. And that's okay, but just don't forget, you haven't gotten rid of the complexity. Now you've moved it into the SDK. You've expanded your system boundary to include the SDK. Now that becomes additional system complexity, right? And that's the lesson. So when I proposed this talk of me just rambling on about complexity, Travis was nice enough to say yes on the condition that I talk about lifecycle. So here's a bolted on section about complexity and life cycles. Feel free to leave, but if you want to stay. Okay, so I got to be honest, the reason I don't talk a lot about lifecycle is I don't have one of my own. I don't have this lifecycle model I can pull out and relate to. So I borrowed the Nordic APIs one. This is from their site. I didn't ask. I hope that's okay. And it's a life cycle, right? So we can imagine that analysis includes understanding what's happening in the business and requirements. Development is design and coding. And operations includes things like release and management monitoring, followed by retirement. With some complexity with the arrows. But we won't get into the actual movement. I will say, and I think Andreas kind of covered this earlier when he talked about life cycle, that this is very macro, right? We know that if you went into higher resolution, there's these other life cycles with dependencies, with documentation and tooling, SDKs, the actual software, the implementation. But we'll ignore that for now. We'll stay at the API as a product level. So here's what we find. In the analysis part of a life cycle, this is the point where complexity gets introduced. It's not when we start design, it's not when we start solving problems, it's when we start identifying the things that we want to solve, the reason we exist, the business, the why, why are we building this? That's when complexity really happens. So If we think about the world, what Don Norman tells us is that the world is complex, and that's good. This is what system complexity tells us too, right? The world is naturally complex. You're familiar with Conway and Conway's law, right? Why do committees invent? The system looks like the organization. What I found when I looked at his paper also, he kind of describes that organizations get formed the way they do because they're managing complexity, right? Imagine one person taking on the responsibility of solving something from the real world, but not being able to manage that complexity and then shifting it down by creating another group and a subgroup. So what happens is we start with complexity in the world, then it gets modeled in the organization, then according to Conway's law, the system looks like the organization, or at least the way they communicate. And then, as Norman says, interfaces end up reflecting systems. So in this way, complexity trickles all the way down to our interface. Now, of course, our job is to deal with that complexity in the design phase, in the development phase. And developers deal with the complexity of the environment they work in, right? The architecture of the application, which we talked about before. So here's an example of complexity in design, something that you might have to deal with. Pagination is a pretty common feature now, right? I'd say one that most people expect. I send a request to your API, you split it up for me into chunks that are manageable. If we looked at this function from a complexity perspective, what would we learn, right? We know there's different strategies. So in this strategy where I do nothing, where I just send you back data, who's paying the complexity price? It's the client application developer, completely. As a designer, I'm ignoring this whole concept of data needing to be split up, right? I let someone else worry about that. If we take an offset and count strategy, where the client application developer has to tell me, start at this item and give me 10 from that point, and that client developer needs to maintain the cursor, we're still talking about complexity on the client app developer side, but now I'm going to take on a little bit of complexity as the designer. I'm going to design the interface to handle this feature. If we move to a fixed page size type of implementation, right, where the client simply sends a request, and by default, I give you a paged, chunked piece of data, and I take it upon myself to maybe provide links and do all that other stuff, I'm going to take more complexity on as a designer. And then ultimately, maybe I could invent smart pagination, where you get the right amount of data for your needs based on context, based on the type of app you are, the type of requests you've made so far, based on all kinds of variables. Then I'm taking on a lot of complexity. Now, I'm not saying you need to constantly think about it in exactly this way, but the reality is every design decision you're making is a decision about whether you want to pay the price for something like this or whether you're going to make client developers pay, right? And keep that in mind. The only way to really improve design then is to start thinking about your interface from that external perspective and having empathy for the people who use the API. In terms of operations, when we get to releases and change, this is where our external bodies actually see the complexity, right? They pay that price in runtime. And where operators deal with complexity. And of course, in retirement, complexity is removed. It's the only way really to get rid of essential complexity, right? By taking the function away. So let's end by looking at what API consumption looks like. We've got two main actors, right? Machines and humans. And it's fair to say right now, machines are the runtime consumer. They use the API as we build it and expose it. And humans are the ones who design these things, develop them, maybe troubleshoot them, all non-runtime activities. We could also say that machines exhibit deterministic behavior, and humans exhibit that adaptive behavior we talked about earlier. And what that really means is when we're thinking lifecycle and frequency of change, I can't make as many changes over here as I can over there. I can change documentation all the time, but I can't change my API implementation easily because this thing might break. The human consumer can handle change, the machine can't. So obviously where there is opportunity for us is to incorporate things like adaptive complexity as a feature, right? making systems where agents are adaptive enough that we can do more revolutions of that life cycle. We can change things more easily because we have more reliability. We'll have software that can handle change. And what's really exciting and maybe possible, and I have no answers on how to do this, is to extend what we think of as our system boundary. So instead of just designing a system that's complex that we use and then treating client app as some other thing, if the boundary gets shifted to encompass the client application and other applications, and the application gets decomposed into these smaller pieces, and those become adaptive, right? Then suddenly we have an opportunity to change constantly, right? And suddenly we have a complex system that's bigger, and we get emergent behavior and all the things we want. But that's all very complex. So the simple version of everything I've said is just this. First thing is accept complexity. Accept that it's part of life. It's going to be there. Don't be scared of it in the APIs you're building. Embrace it, right? Complexity and all the functions behind it are what make your organizations what they are. But you do have to manage complexity, and that means you design, improve usability, improve learnability, right? Expose that stuff in a way that you'll make people's lives easier. And then maybe in the future start thinking about how to incorporate things like system complexity. But make sure you learn about that from someone who knows what they're talking about, not from this talk or from me. That's all I have. Thank you.